So we're in C now. We must prove that if alpha is ordinal, then S alpha is an ordinal. Okay? What is an ordinal? It's just a transitive set in which all its elements are transitive. Okay? So alpha is ordinal. We must prove that S alpha is also ordinal. Okay? I will try to explain it using a tree. So, a tree, no, without tree. No. Without 3, yes. So, we must prove that S alpha is ordinal. So, for X is in S, why S alpha is first is transitive is because we already proved that if alpha is transitive, then S alpha is transitive. So we must prove then for all elements X in S alpha, X is transitive. Okay? Which means for all Z, for all Y, if Z in Y and Y in X, then Z is in X. Okay? So we must prove that. For an element Y or for an element X in S alpha, by definition, S alpha is alpha union alpha. Okay? So we have two situations. Whether X is equal to alpha, because belonging to this set, or X is an element of alpha. The first is X is belonging to this set, which means X is equal to alpha, or alpha is ordinal, then X is ordinal, which means X is transitive. So we have nothing to prove then. But if X is an element of alpha, we know that alpha is ordinal and all its elements are transitive, so X is transitive. Then all the elements of S alpha are transitive, so S alpha is transitive and all its elements are transitive. Then S alpha is ordinal. Okay? We proved that. So if X is transitive, then the union over X is transitive. Okay? I will denote by A the union over X, the big union, with X is transitive. So why A is transitive? So let Z and Y such that Y is an element of A and Z is an element of Y. So why we have Z is an element of A? So we know that Y is an element of A, and A is the union over X. by definition, this is the union over V, and V belonging to X, which means there exists a V in X such that Y belonging to V and V belonging to X. X is transitive, so Y is an element of X. And we know that Z belonging to Y, okay? And Y belonging to X. So, because Y belonging to X, Y is belonging to the union over X. Sorry, no. Yes. No. We have Y belonging to E, and the E is the union of over the big union. By definition, the big union is the union of V and V belonging to X. So, which means there exists a V and Y belonging to V. So there exists a V who belongs to X and Y belonging to V. Okay? So by the transitivity of X, we have Y is an element of X. Okay? So if Y is an element of X, what we can do now, what we can say about Z. So we have Y is an element of X. So, yes, so the union, so Y is a subset of the union over V for V belonging to X. We have this. And we have Z is an element of Y. So, and Y is a subset of this set, and this set is A. Then Z belongs to E, and E is transitive. Okay? So, by transitivity of X, we prove that A is transitive. Then we move to E. If alpha is ordinal, then every beta who belongs to alpha is an ordinal, which means all the elements of an ordinal set are ordinals. So in this case, I will describe it using a tree. So we have alpha here. Okay? This is ordinal. And we have the elements, its elements, beta, for example, beta 1, and beta 2, etc. etc. We have too many. So we know that alpha is ordinal. Y, beta, is also ordinal. Okay? So for beta to be ordinal, it should be transitive, and all its elements are transitive. Okay? For gamma, we must prove that beta transitive for a random beta here. Okay? And for all gamma, also transitive. Okay. So we know that alpha is ordinal. What that mean? It means that it is transitive, which means, or we will not use the transitivity of alpha. We'll use the transitivity. No. So we must prove that beta is transitive. No. Beta is transitive by the definition of ordinality of alpha. We know that alpha is ordinal and beta is an element of alpha, then an element of an ordinal set is transitive, because alpha ordinal, which means it is transitive and all its elements are transitive. Okay? So beta is transitive. We know that beta is transitive. We must prove that alpha is also transitive. Why alpha is transitive? We know that alpha is ordinal, which means alpha transitive. And we have alpha transitive, so for this element, by transitivity, this element belongs to alpha, because alpha is transitive. We have gamma belongs to beta, and beta belongs to alpha. And by transitivity of alpha, we have gamma belongs to alpha. So we can say that this alpha is linked directly with alpha, which means gamma is an element or belongs to alpha. And we know that gamma is ordinal, which means it is transitive and all its elements are transitive. Or alpha or gamma is an element of alpha, so it is transitive. So we prove that gamma is transitive. Then beta is ordinal. So all the elements of an ordinal set are ordinal. Okay? So I think it's easy to describe it with a tree. So we are here. So if X is a set of ordinals, then the union over X is ordinal. So it's not the same as. Now, we've proved that if X is transitive, then A is transitive. Okay? So we have this. X transitive imply the union over X is transitive. I denote this set as E. So we have the transitivity of E, and why all elements of E are transitive. Okay? Because we will suppose that alpha is ordinal. Okay? Is that what the demand? If alpha is an ordinal, then yes, no. If alpha is a set of ordinals, then yes, this is not, X is not transitive or ordinal. It's a set of ordinal. X is a set of Y ordinal. Why the union? It's not the same as before. why the union over X is an ordinal. So we must prove that A is transitive and all its elements are transitive. Okay? So let Y be in E and Z be in Y. Y, Z belonging to E. What we know, so the definition of the union over X is the union over V for V belonging to X. So for Y to be belonging to E, it must there exist a V in X and Y belonging to V. What we know about V, V is ordinal because V belongs to X and X is the set of ordinals. So V is ordinal and Z is belonging to Y and Y belonging to an ordinal set. So this is transitive. Okay? By the or V is transitive, so Z must be belonging to V. We have this. So if we have this, then Z must belong to the union of V in X, and this is the union over X, this is A. So we proved that A is transitive. So Y is transitive, is also transitive. So we must prove that for Y in E, Y is transitive. Okay? So we must prove that for Z in Y and for T in Z, this implies T belonging to Y. Okay, what we know that X is the set of ordinals. So Y belonging to the union over X, which is the union over V, and V belongs to X, which means Y belong to V for V belongs to X. X, V is ordinal, then Y is transitive. Okay? So it's easy, I think. It's easy. So Y is transitive, and then A is transitive also. A is transitive. All its elements are transitive. Then A is ordinal. Okay? So that's it.